In this video, we will be going over cross-entropy loss. We have seen how to classify text given pre-trained weights and bias. Now the question is, how do we find good values for the weights and bias? The answer is training. From our requirements needed to train logistic regression, this video will focus on the objective function that we want to optimize. When we train a supervised machine learning model, we are often given a set of training data. One sample of training data comes in the form x, y, where x are features and y is the true class. When we use a model to predict the class, we call that prediction y hat. When we train, we are given a training sample, which is a pair of a feature vector and a true label, which we call x and y respectively. Our model likely won't predict the class correctly. This is because we haven't trained our weights. Right now our weights are all 0, same with the bias. Let's go ahead and try to classify given our training sample and our untrained weights and bias. 0 times 3 is 0, 0 times 1 is 0, 0 times 0 is 0, and adding all those zeros together gives us 0. Now let's use our sigmoid function, which is 1 over 1 plus e to the negative z, where z is 0. E to the 0 is 1. 1 plus 1 is 2. 1 divided by 2 is 0.5, which means that our probability of y being 1 given x is 50%. Given our decision function, where we set the boundary to be 0.5, since 0.5 is not greater than 0.5, the predicted class is 0. But the true class is 1. Our model predicted incorrectly. To improve our prediction, we need a function to calculate how different the predicted class is from the true class. We call this function a loss function or cost function. A loss function tells us how much the predicted class differs from the true class. In our case, we will use a specific loss function, cross-entropy loss. Cross-entropy loss measures the distance between the true class and the predicted class. The closer the predicted class is to the true class, the smaller the cross-entropy value will be. Let's break this equation down. Notice that we are comparing the probability of the labels instead of the actual labels themselves. Notice that the two parts of our equation fundamentally change the equation depending on what value our true y value has. If the true class is 1, then when we plug in y, we see that one of the values becomes 0. Notice that this 0 actually removes the entire second part of the equation. It completely disappears from our calculation, and we are left with just the left side of the equation. So cross-entropy loss becomes the negative log of the probability that the class is 1 given x. Meanwhile, if y equals 0, we see that the other side of the equation will drop out. The left side of the equation disappears, and we are left with the right side of the equation, where cross-entropy loss is the negative log of the probability of the class being 0 given x. These videos were inspired by Josh Starmer at StatQuest. Be sure to check them out.